This is it, the last of the implicit differentiation examples. And this one is just asking for something that is, well, a quantity that you've done before, just a second derivative. No big deal, but what does that look like when you're doing it implicitly? Well, once again, I'm just going to go ahead and quickly take this derivative. I made it a pretty simple derivative, so it shouldn't be too hard. 2y dy dx equals negative 2x. And by the time I actually get done rewriting this, I have negative 2x over positive 2y. Negative x over y. That is my first derivative. Yay! So taking the second derivative shouldn't be much more difficult. By the way, this is how we can show that we're taking the second derivative. Just a little symbol work there. But what special rule will we use here? If you guessed that we should be using the quotient rule, you are correct. We'll take the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator all over the denominator squared. Well, now, that looks very different, but not too bad, was it? There's only one small problem here. That is the fact that, man, we still have a dy dx in the answer. That seems a little odd. I don't know, is that something that we want there? Probably not. This was originally written in terms of just x and y. In fact, this is what's known as a differential equation, not something I want to start up with right now. So let's save that till, a later point in time. And let's get down to how we're going to solve this. Well, it's still the second derivative. Everything's lined up nicely. I think we're in good shape, except what do we do with that derivative? Well, the good news is we already solved for the derivative. In fact, it's written in blue over towards the left. Do you notice this here? That is the first derivative. You can substitute that directly into your equation here. It does say dy dx. Why not just say what dy dx is equal to? It makes for a perfectly ugly sort of situation here because now I have negative y minus x squared over y all over y squared. That's a complex fraction. I think it's safe to say that those are not my friend. I don't want to write my final answer as a complex fraction, but I can get rid of that by handling my business algebraically. Hopefully you notice that little denominator hanging out there. We can get rid of that denominator by multiplying everything by that denominator. Yep, it's true. It won't be hard to do. Y times negative y. Y times x squared over y. I think the y's in this second one are going to divide out. And on the bottom, y squared. Oops. Times y would be equal to y cubed. One would think you're good to go, and as a matter of fact, that is the correct answer for this problem. We can even go one step farther. Let's see if you can figure this out. I have negative 100 over y cubed. Does that make any sense to you? How did we get that? Well, you know what? It says up here in the original problem that x squared plus y squared is 100. I have negative x squared plus y squared in the numerator. So that should be equal to negative 100. To take a second derivative, you just do the derivative twice, but you will always end up with a dy dx somewhere in that second derivative. No big deal. Just use some substitution and then rewrite your problem appropriately. That's it. Nothing new or special, but there's just that little trick of substitution. Hope that helps, and we're off to do some more implicit practice now.